So in our second trigonometry video, this time we're going to look at how we find missing angles within a right angle triangle. If you haven't already, it's extremely important that you watch the first lesson on how we find a missing side, because a lot of the same stuff is going to be used here. So for example, and just a quick recap, so ka toa, which again you'll remember from the first lesson, is the saying that we use that helps us to remember our three different formulas for trigonometry. Sine theta, so SOH, equals opposite over hypotenuse. Cos theta equals adjacent over hypotenuse, that's given us by ka. And tan theta equals opposite over adjacent, that's toa. So depending on the sides within the right angle triangle and whatever particular equation we're doing, if we're using opposite and hypotenuse, we're using sine. If we're using adjacent and hypotenuse, we would use cos. If we were using opposite and adjacent, we would use tan. So these type of equations are very similar to the ones that we looked at where we found missing sides, and the first couple of steps are pretty much the same. The first step being, so if we look at this question where we identify the known sides, in this question we have a right angle triangle. We're asked to find x. X is the missing angle. I've written theta in here as well because theta is the angle within the formula, okay? That won't always be written in, but I've taught you that in this formula we're using sine theta or cos theta or tan theta, theta being the angle. Our first step is to identify the known sides. So if you remember, the known sides in this case are the 9 centimeters and the 5 centimeters. We are not using this side along the bottom because we don't use it, or we don't know it, sorry. So the 9 centimeter side is opposite the right angle, is the longest side, so therefore it is the hypotenuse. So I'm putting a H here for hypotenuse. This side that is labelled 5 centimeters is opposite the angle that we're given, so therefore it is the opposite. So we're using opposite and hypotenuse. So ka toa, opposite and hypotenuse, means we're using sine. So the second step being decide the trig function, we're using sine. So sine theta equals opposite over hypotenuse, okay? The next step, again, everything is the same so far as the first video when we were finding a missing side. We substitute in our values. So theta is the angle, so you can either leave it as theta, or in this case it was called x within the question, equals opposite. The opposite is 5 over the hypotenuse, which is 9, and this is where it's now a little bit different. We are trying to get x, we're trying to find x on its own. So what we are going to do, we are going to use the inverse trig function. So just to show you, and it will depend on your calculator, we want to get x on its own. So if we're moving sine across the equals, like anything we move across an equals, it does the opposite. So sine becomes sine to the minus 1, okay? So x equals sine to the minus 1 of 5 over 9. So all I've done is I've moved sine from the left hand side to the right hand side, so it now becomes sine to the minus 1 of 5 over 9. So if on my particular calculator, it'd be the same on most mixed calculator. If you remember here, sine, cos and tan, these are our trig functions. Sine to the minus 1 is above that, and because it's in this orange sort of font, I am using the shift function in the calculator. So I push shift, and I'll see that that now allows me to use sine to the minus 1 of, in this case, 5 over 9. So I'm using brackets, 5, there's my fraction button there, over 9, close the bracket, and that gives me 33.7 to 1 decimal place. I'm going to give my answer to 1 decimal place. In this case, it will usually tell you what degree of accuracy within the question, and it is degrees because it is the angle that we have found, okay? The second question, done very much the same, okay? So we're just again going to follow these steps. Identify the known sides. So here's my right angle up here. This is the angle that we know. We're not using this side, we're using the side that is beside the angle that we're trying to find, so that is therefore the adjacent. This side that is 7 is opposite the angle that we're trying to find, so it is the opposite. So we're using opposite and adjacent, so therefore we're using tan theta toa equals opposite over adjacent. We substitute in our values, so tan theta, which is what we're trying to find, equals opposite, which is 7, over the adjacent, which is 6. We use our inverse function, so it becomes theta equals tan to the minus 1. I've just moved the tan across, and it becomes tan to the minus 1, 7 over 6. and then we simply put this into your calculator. Shift tan to the -1, open bracket, 7/6, close bracket, and 49.4 to 1 decimal place is my answer for this particular question. Okay, so that's how we find a missing angle within trigonometry. I'll post some questions for you to try, and in the next lesson on trigonometry, we'll look at some questions asked within the context of worded questions or where there's a diagram or something of that nature.